Let's take a look how trig ratios can be used in applications. The two main uses are for the angle of elevation, also known as the angle of inclination, and the angle of depression. So let's start with the angle of elevation. So the angle of elevation is created when your line of sight is looking up at an object. The angle of elevation is created by your line of sight. So your line of sight in this picture would be the hypotenuse, and then a horizontal line, which would be the adjacent leg to your line to your angle of elevation. Okay, so the angle of elevation is that angle right there in between those two. That angle of elevation is important because it can help you find the height of something. It could help you find how far away you are for something. Maybe you're looking for the specific degree angle. There's a couple things that it can be used for. The most important thing is to make sure that you set up your figure and you label your sides correctly. So in our first example, we have Casey, who sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If he is 6 feet tall, how far is he standing from the base of the lighthouse? So the picture that goes with this is actually the same picture in that description of angle of elevation. So I'm not super creative with my drawings, but here we go. It'll be the best I can possibly do. Here's our lighthouse. And you don't have to, go crazy with your drawings. You can just draw a right triangle. We know we're going to have a right triangle. We know that this lighthouse is 84 feet tall because that's what was given to us. We've got Casey standing over here. He is 6 feet tall. I guess it could be a she. Doesn't? Oh no, it does say he. 6 feet. He is. We don't know how far away he is from the lighthouse. That's actually what we're trying to find. But we know from his line of sight, it is. That's not really drawn very well because that's to the top of the lighthouse, so it should be all the way to the top. His line of sight, and then the horizontal, that would create a 58-degree angle. Because he's 60 feet tall, this little triangle that's created here is going to be missing that 6 feet. So it's not the entire length of, or the entire height of the lighthouse. It's 84 feet minus 6 feet. So that actually makes that, 78 feet. And again, we're still looking for how far away he is from the lighthouse. So if we're looking at this picture, from the 58-degree angle, 78 is the opposite leg and X is the adjacent leg. So we are going to use tangent of 58 degrees equals our opposite, which again is 78 because we had to take the 6 feet out of the 84 over what we're looking for, which is X. I would suggest setting up a proportion, cross multiplying, X times tangent of 58 equals 1 times 78, which is 78, and then divide both sides by tangent 58. We do that, we'll go to our calculator and type in 78 divided by tangent of 58. Make sure you don't do the inverse tangent because we have the angle, so just regular old tangent, and we should get that he is standing about 48.7 feet away from the lighthouse. For our second example, this is the angle of elevation from a kicker's foot on the football field to the top of the goal post bars is 17 degrees. So we've got our kicker, his foot's down here, there's the ground, here's our goal post. So from his foot to the top of the goal post is 17 degrees. That's going to create a right triangle. We want to know how tall the goal post is. and we know he's standing 131 feet away. Again, you don't have to be really elaborate with these pictures. You can just draw right triangles. I'm trying to be a little bit more elaborate in notes just so you can kind of get a better visual for what's going on. X is our opposite leg, and the 131 is our adjacent leg, so we are going to be using tangent. We know the angle, so tangent of 17 degrees equals opposite x over adjacent 131. Create a proportion and cross multiply. X times 1 is just x equals tangent 17 times 131. We're going to do 131 times tangent 17, and we'll go straight to our calculator because x is already isolated. So 131 times tangent 17. The goalpost is about 40.1 feet tall. Angle of depression tends to be challenging for students because they want to put the angle in the wrong place. So an angle of depression is used when you're looking down on an object. So you are above the object. It is created by your line of sight. So in this picture, again, the line of sight is going to be the hypotenuse and a horizontal. So the angle of depression is this angle right here. The mistake that students make is they want to put the angle of depression here instead. Be really careful when you're doing this. Okay? When you're looking up at an object, your triangle should look like this, and this would be your angle of elevation. But when you're looking down at an object, your triangle should look like this, and this will be your angle of depression. Okay? Be really, really careful. Always between the horizontal and the line of sight, which would be the hypotenuse. So for example 3, says a lifeguard is sitting on a platform looking down at a swimmer in the water. So this is actually the picture that we were just looking at. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? All right, so we've got our swimmer down in the water. Okay, let's put our little swimmer down here. And then we've got our lifeguard sitting up in this chair. Here they are up here. Okay. Their horizontal is here. Their line of sight is there. So our right triangle is going to look like this. The angle of depression is 18 degrees. So line of sight and horizontal. We know that they're sitting 8 feet up, so you can put the 8 feet here or you can put the 8 feet there. It still is the same thing. And we're trying to figure out how far away they are from the swimmer. So we're looking for that horizontal distance. So you can label that here or here. It's the same thing. So if I'm looking from that 18 degrees, 8 is the opposite and x is the tangent. So is the adjacent, which means we're going to use tangent. Getting ahead of myself. So tangent of 18 degrees is equal to 8 over x. Cross multiplies, I'm going to get x times tangent of 18 degrees equals 1 times 8, which is 8. We're going to divide both sides by tangent 18 degrees. And then we will go to our calculator. Again, we're using regular tangent, not inverse tangent, because we know the angle measure. The only time you're going to hit that inverse button is if you do not know the angle measure. So the lifeguard is about 24.6 feet away from the swimmer. You'll find a lot of word problems tend to use tangent because typically the line of sight isn't a measurable distance. It's not true in all cases. There are some examples that will do that use sine or cosine. If you were flying a kite, and that hypotenuse would represent the string of the kite. If you had some sort of wire tethering something down, then we would know the hypotenuse. So tangent is used quite a bit, but it's not the only thing to use. All right, last example, a pilot in a helicopter spots a landing pad below. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude, also known as the height, of the helicopter? So we've got our helicopter. This is going to be an awful helicopter, but you guys kind of get the idea of what it looks like. There's a landing pad somewhere down here, so it's got the big H on it. Okay, so from the helicopter, let's make our right triangle. The angle of depression is between the line of sight, which is the hypotenuse, and the horizontal. So that's 73 degrees. The horizontal distance is 1,200 feet. And we're trying to figure out the altitude or the height of the helicopter. So this is going to be our setup. The X is going to be opposite from 73 degrees, and the 1,200 is adjacent. So once again, we are using tangent of 73 degrees equals X over 1,200. Cross multiply, 1 times X is X, which means X is isolated, and then we're going to do 1,200 times tangent 73. We'll go to our calculator, 1,200 times tangent 73. Our helicopter is approximately 3,925.0. This was feet